As the basics of factors and factoring is a fairly complicated or lengthy process, I went ahead and split this into two sections. So we're going to go ahead and talk about basics of factors and factoring now that we understand composite and prime. So we will want to understand basic multiplication and division in order to finish off this section. Being able to recognize whether a number is prime or composite is one of the basic pieces of information that we will need when it comes to factoring. Once you understand these concepts, you can move on to factoring whole numbers. So, factor actually has two definitions. The first one is, as a noun, this is a number that divides a given number. Saying a number is a factor is the same as saying it is a divisor. For example, we can say 2 is a factor of 6. We can also talk about factoring as a verb. To factor a number, we want to write it as a problem involving multiplication. So for instance, 6, if I wanted to factor it as a verb, is equal to 2 times 3. The last vocabulary that we have is prime factorization. Prime factorization means writing as a product of primes. So for instance, in the previous example, 6 equals 2 times 3. Since 2 and 3 are both prime numbers, that would be considered the prime factorization. When it comes to problems involving factors, we have two different methods that we can use. The first one is finding all factors for a number. So to do this, we want to start with 1 and the number, and from there we want to check each number, 2, 3, 4, 5, etc. If it divides evenly, we want to keep it, as well as the quotient or the result. If it doesn't divide evenly, move on to the next number. You will continue this process until you reach a number that is already on the list. So let's look at some examples. If we look at 50, we want to start with the number and 1, or 1 and the number. From there, we want to continue with 2. Does 2 divide into 50? Yes, it does. And so we get 2 and 25. Does 3 divide into 50? No, it does not. 5 plus 0 is 5. 5 is not divisible by 3, so 50 is not divisible by 3. Try dividing 50 by 4. 4 does not divide evenly into 50, and therefore it is not a factor. The next number we have is 5. 5 does go into 50, and it goes in 10 times, so we want to add 5 and 10 onto our list. We don't need to worry about 6, since it was not divisible by 3. It's not going to be divisible by 6. We don't need to worry about 7. 7 does not divide into 50. 7 will get you to 49, but not 50. We don't need to worry about 8, since it's not divisible by 4. It will not be divisible by 8. We don't need to worry about 9, since it was not divisible by 3, it's not going to be divisible by 9, which brings us to 10. Since 10 is already on our list, these are all of the factors. Let's look at the next example, 35. 35, we have 1 and the number. Is it divisible by 2? It's not an even number, so it will not be divisible by 2. It's not divisible by 3. If you add the digits, you get 3 plus 5 is 8. Since 8 is not divisible by 3, 35 is not divisible by 3. Since the number was not divisible by 2, it's not going to be divisible by 4, bringing us to 5. Since it ends in a 5, it is divisible by 5, and if you divide 35 by 5, you get 7. So we want to add that onto our list of factors as well. 35 is not divisible by 6. Next number is 7, which is already on our list, and therefore we are done. For our next example, let's look at 81. We're going to go ahead and start with 1 and the number, and then continue. 81 is not divisible by 2 since it's an odd number. 81 is divisible by 3 since if you add the digits you get 9. Since 9 is divisible by 3, 81 is divisible by 3. If you divide 81 by 3, you should get 27. 81 is not divisible by 4. It's not divisible by 5 since it ends in a 1. It is not divisible by 6 since it's not divisible by 2. 81 is not divisible by 7. 7 will get you to 77 or 84. It's not divisible by 8 since it was not divisible by 2 or 4, which gets us to 9. If you add the digits, you get 9. So it is divisible by 9, and 81 divided by 9 is 9. You only have to write the number once since it is a repeated factor. 2 more examples. Let's look at example D. Example D, we have 32. Starting with 1 and the number, we have 1 and 32. From there, let's go ahead and divide by 2. 32 is divisible by 2, and if you divide 32 by 2, you get 16. 32 is not divisible by 3. If you add the digits, you get 5. Since 5 is not divisible by 3, 32 is not divisible by 3. Is it divisible by 4? Yes, it is. So we can go ahead and add 4 onto our list, and if we divide 32 by 4, we get 8. From there, we want to check 5. 5 does not divide into 32 since it ends in a 2, not a 0 or a 5. It is not divisible by 6 since it was not divisible by 3. 32 is not divisible by 7. 7 will get you to either 28 or 35, which brings us to 8. 8 is already on our list of factors, and so these are all of the factors for 32. Finally, for the last example, 56, we have 1 and 56. Is 56 divisible by 2? Since it is an even number, it is. And if we divide 56 by 2, we should get 28. 56 is not divisible by 3. If you were to add 5 plus 6, you would get 11. 11 is not divisible by 3, so 56 is not divisible by 3. What about 4? If you use your calculator, you should see that 4 does divide into 56, and we get a result of 14. 56 is not divisible by 5. It's not divisible by 6, since it was not divisible by 3. Is it divisible by 7? Yes, and it goes in 8 times. The next number in the sequence would be 8. Since that is already on our list, we are done with our factors. So as I mentioned, there's going to be two things that we talk about when we talk about factors. We've already looked at the first one, which is listing out all of the factors. And now the second one that we're going to talk about is prime factorization. Prime factorization, recall, is writing a number as a product of primes or multiplication of primes. So to do prime factorization, the first thing that we want to do is find two numbers, any two numbers that multiply to the given number. Do not use one and the number. For each number, we want to determine if it is prime or composite. If it is prime, circle it. If it is not, if it is composite, we're going to repeat steps 1 and 2. We want to continue the process until there is nothing left to factor. From there, we have take all the numbers that are circled and write it as a product. If you have repeating factors, you can use exponents. We'll see an example of this in just a few minutes. So let's look at some examples of using prime factorization. If we start with 27, I want two numbers that multiply to 27. 27 is divisible by 3, and if you divide 27 by 3, you get 9. 3 is a prime number, so I'm going to circle it. 9, however, is not, so I do need to factor this further. It is equal to 3 and 3. Both of these are prime, and we have reached a state where we cannot factor any further, and so we are done with our factorizations. So 27 is equal to 3 times 3 times 3. Basically take all the numbers that you circled, or you can write this with exponents. Our base is the 3. The exponent is how many 3's do we have multiplied together. Since we have a total of 3, we can write this as 3 cubed. Let's look at example B now. Example B, we have 42. So we want to pick two numbers that multiply to 42. And keep in mind that there is no one correct way to do the factorizations. 42, for instance, I could pick 6 and 7. 6 factors further, it is not a prime number. 6 is equal to 2 and 3. 7 is prime. 2 and 3 are both prime, and I am left with nothing else left to factor, so I get 42 is equal to 2 times 3 times 7. Now, as I said, you can do this several ways. So for instance, let's look at this again and pick other numbers. If we pick some other numbers, we can do 2 times 21. 2 is prime, 21 is not. 21 equals 3 times 7. Irregardless of how you factor this, we should get the same answer. 2 times 3 times 7. So, let's look at some other examples now. Let's look at 80. For 80, I want to pick two numbers that multiply to 80. From off the top of my head, I come up with 8 and 10. 8 is not prime, it is equal to 2 times 4. 10 is not prime, it is equal to 2 times 5. So now which ones are prime here? We have 2 is prime. 4 is not. We can break that down further into 2 and 2. 2 is prime, 5 is prime, and hopefully the other two 2's are still prime. So now that we have factored this and cannot move any further, we can go ahead and write this out. This is 2 times 2 times 2, I think that was 4 2's, times 5, or 2 to the 4th times 5. For the next example, 128. What are some numbers that multiply to 128? You don't have to worry about thinking too hard on this. For instance, I know it's divisible by 2, so let's start with that. I get 2 and 64. 2 is prime, so I can circle it. 64 is not. I can divide that by 2 as well and get 32. Again, 2 is prime. 32 is not. I can break this down to 2 and 16. 2 is prime. 16 is not. We can break that down to 2 and 8. 2 is still prime. 8 is not. We get 2 and 4. 2 is prime. 4 is not. That is equal to 2 times 2. Okay, so that was a very long process. But one of the things to note is that one of the things that you can do when you do your factor trees is, I consider this kind of like math topiary. If you set it up where you are always dividing by the smallest number, you get a nice shape where all you have to do is basically follow the line all the way around the number. You don't have to worry about things being hidden inside your factor tree, like over here. So, for our final answer, I'm just going to write this in exponential form. We have 1, 2, 3, 4, 5, 6, 7 2's. So this is equal to 2 to the 7th. Irregardless of whether you pick two random numbers or the smallest number each time, again, you should always get the same answer. So let's look at 204. 204 is divisible by 2. We get 102. 2 is prime. 102 is composite. This breaks down to 2 and 51. 2 is prime. And what about 51? 51 is divisible by 3. If you add the digits, you get 6. Since 6 is divisible by 3, 51 is divisible by 3, and it is equal to 3 and 17. 3 is prime, and 17 is also prime. So now that we are done with our factorization, we can go ahead and write it as a product. We have 2 times 2 times 3 times 17, or 2 squared times 3 times 17. This concludes our basics of factoring. Note that factoring, we will see this throughout the semester. The first place that we are going to see it is later in this section when we get to part 4 of 8.2. We will apply basics of factoring when we talk about simplifying fractions. We will expand the concepts of listing out all factors when we discuss factoring polynomials in Chapter 6. And we will expand the concepts of listing out prime factors and prime factorization when we discuss simplifying radicals in Chapter 8.